My name is Jian Lange. I'm the product manager for spatial analysis at Esri. Today, I'm presenting with my colleague Vicky Cove. Vicky works for the geoprocessing team, which is part of the software development department at Esri. Welcome to our tech workshop, and this is actually Vicky's first users conference talk. She just joined us last year, and Vicky is a biologist and she has an advanced GIS degree, and I'm really happy that we're always hiring and expanding, and then I get to work with really smart young people who brings in fresh ideas. So here's the agenda for this tech workshop. I will start with a brief introduction to ArcGIS Spatial and ArcGIS Online Spatial Analysis, what it is, what do you need in order to run spatial analysis in ArcGIS Online, and what kind of tools are included. And then Vicky will walk you through with the recommended steps or workflows of performing analysis online. And then our focus really is the third part, which are the demos and examples. So we want to show you how you can choose different analytical tools from ArcGIS Online and use that to solve specific problems. And then I'll wrap up, and then our plan is to leave some time at the end to answer some of your questions. So let's get started. Before I start with the specifics of ArcGIS Online spatial analysis, I want to talk a little bit of ArcGIS just to give you a perspective. When I started working for Esri in 1995, so it's more than 20 years ago, and at that time, the picture was very different. So we had ArcGIS, mainly a desktop application, and the people who can use ArcGIS typically needs to take some GIS training, like you need to have some domain expertise. Things today are very different. We can, in ArcGIS, we see it today as a complete platform, including online, desktop, server, mobile, developer, and solutions. So it actually can be used by domain experts, and the apps can be used by basically anybody. And then you can access ArcGIS Online through the web, through your mobile device, and through desktop, of course. And the services can be hosted in the cloud, which is the case in ArcGIS Online. And these services can also be hosted in your own ArcGIS server portal. So how does analysis fit in the ArcGIS platform? And for us who work in the analysis team, we would like to say it is the most important piece. It truly brings the power of GIS by analyzing the spatial data, by understanding how the spatial data relate to each other, and that's how you can really solve complex problems and how to gain useful knowledge. And analysis is across the whole platform. You can run analysis on desktop, of course, and on the web in ArcGIS Online as well as in ArcGIS Server. And you can run analysis services through your mobile device. And then there's a new concept called online content and services, which means these analytical services, not only it includes the analytical tools, it also comes with the data that's required to use for analysis. An example could be using routing services. You really don't have to worry about the network data or traffic data. The part of the routing service includes the network data. And using elevation services to find out a vertical profile along a path, you don't need to worry about acquiring the elevation data for the area that you study. Okay, so our focus in this specific workshop is basically analysis on the web, and I'm going to show some demos as well as Vicky show some demos that use content and elevation services as well as network services. And then our platform today for this tech workshop is the ArcGIS Online. Okay, so what is ArcGIS Online Spatial Analysis? Basically, it is the analysis that's integrated into the ArcGIS Online organization. How many of you are already using ArcGIS Online? Oh, great. So more than half. So for those of you who are not familiar with ArcGIS Online, basically it is a hosted GIS, hosted in Esri cloud, and as an organization you can have a subscription and then host with this organization, your ArcGIS Online organization will be able to host your data content, and now you'll also be able to analyze your spatial data within your organization using these spatial analysis capabilities. Yes?
To use spatial analysis on ArcGIS Online, does it require licensing?
Perfect questions. What do you need? You do need to have a subscription to your ArcGIS Online, and then you do, as an administrator, when you set up your users, you need to grant these users analysis privileges.
So I have a spatial analysis license for my desktop.
Yeah.
Do I need a spatial analysis license for ArcGIS Online? Are they one and the same? Or
They are not the same type of licensing thing. So,
I have access to ArcGIS Online
yeah.
without account.
Okay. Yeah. That.
Does ArcGIS Online require a separate spatial analysis license?
It doesn't, but that's not how ArcGIS Online works. The ArcGIS Online, so you have a desktop. So to answer that questions in a simple way, when you have a desktop license, it granted you an ArcGIS Online login, and it gives you a certain amount of credits. I don't remember the exact number. Say it gave you 300 credits. And every time you run analysis or host your services, it consumes some of these credits. So when you run out of credits, you need to acquire more credits. So that's how it works. So, as a user in the organization, in order to run analysis services, they need to have the privilege. So the administrator has to grant them analysis privilege. And also, the analysis services do consume credits. So every time you run a certain operation, it takes out a certain amount of credits. So what kind of spatial analysis tools are included with ArcGIS Online Spatial Analysis? What we did was, as a team, the analysis team, we sat down and we did research what are the most used geoprocessing type of solutions that people are using, right? And then we, in ArcMap, how many of you are using geoprocessing in ArcMap? Okay, we have about 800 tools, geoprocessing tools in ArcMap. So obviously, we do not want to duplicate these tools in ArcGIS Online. So we identified originally 14 most commonly used workflows by 80% of our users, and we made them available in ArcGIS Online. So there are about 6 categories of analysis tools roughly related to what you need to do. And I'm going to go through each of these categories very briefly, and later on both Vicky and I will show some demos that demonstrate almost tools and pretty much in every category, so you get an idea. The first one, summarize data. And in this category, we have tools that allows you to calculate summary statistics for some spatial features within a certain boundary. An example could be, I would like to find out what is the average school performance within each of my school districts. So I have schools as point data. I summarize these points within each of my school district boundary, and then create summarized statistics for my school performance data or any attributes you like to do. Next category, find locations. This is a really powerful solution which does not really exist in ArcMap, in this user experience. Traditionally in GIS, we provide a strong, powerful query tools, allows you to query your spatial data. These queries can be spatial queries as well as attribute query. An example of a spatial query would be I would like to find parcels that is within 2 miles of a river. Or I would like to find parcels that's completely within this specific district. These are spatial queries. And I can also do attribute query. Example would be, give me all the parcels that has population greater than 5,000, or give me all the empty parcels. So you have an attribute, you can do a type of SQL query. So what we found out that you need to train people to know you're performing a spatial query or attribute query. So in ArcGIS Online, when we design these query, we call it find locations. Basically, we don't require people to know are they performing a spatial query or attribute query. You'll see a demo later on, Vicky will show you. And all you need to say is find all the parcels. That is, owner is last name starts with L, and then population greater than this, and adjacent to this parcel, and so on. You can just combine them, and then in this level, and then you can just go ahead and run it. Okay. Data enrichment, one of my personal favorite tool. I give many talks on using spatial analysis, and I always tell people, although it seems difficult to find what is the right analytical techniques, most times 80% of your effort is spent on finding the right data. You want to do viewshed analysis, but you have to acquire the right elevation data in the right resolution, and you want to perform some business analysis, then you have to find out the demographic information within your area. So what the data enrichment allows you to do is to enrich your existing spatial data with additional demographic and lifestyle data, and even landscape. We have many categories available depending on which area you are in the world. In fact, I think we have more than 100 countries data available. So you could select the area you're interested in, the type of data you're interested in, and then add these data that fits your existing geography. And to me, that's a very powerful feature. And then you can run your analysis based on that data. Analyze patterns. These are typical spatial analysis tools, allows you to understand the distribution of your spatial data, calculate density. You can use it to create a crime incident density map so that you know which area in your city the crime mostly occur. And you can use find hotspots, cold spots to get statistically significant hotspots, cold spots for specific spatial phenomena. And you can use interpolate points to perform spatial interpolation. And the algorithm behind the scene actually is quite advanced. It's used in our geostatistical analysis extension for desktop. It's empirical Bayesian kriging. So what this allows you to do is that based on your sample measurements for existing locations, Say example, in California, we have a lot of monitoring stations monitors the ozone level in the air. And then we can use that sample measurements and create an interpolated surface so that we can have a predicted value of anywhere in California. Yes?
Are all these analysis tools limited to point data?
No. Interpolate points, yes. Yes. But calculate density, you can use it for lines or points. Find hotspots, you can use it for polygons or points. Yeah, these are not. It depends. It's all in the help.
I would use like a lot of the census block data and stuff, and you can't like, you could symbolize it like as a heap, but you can't like find like interpolated data off the polygon.
Not in ArcGIS Online. Yeah. Again, as I mentioned earlier, we identify the most commonly used workflows. But if you really, we have other products in ArcGIS platform which may address that specific need. Okay? Use proximity. Proximity analysis basically answers the question, what is near what? So you can do basic proximity analysis like create a buffer, and then a network analysis like create drive time areas. So this would be based on an existing transportation network. We have data pretty much cover the worldwide data, and you can find the data coverage in the help file. And then the create drive time areas not only creates the drive time, you can specify your travel mode as drive time or drive distance, walking time, walking distance, even truck time and or rural driving time or rural distance. Okay, manage data. Data management is not really analysis per se, but we often have to do some data management before you run your analysis. For example, you have files in different layers. You might want to merge them first. You might want to dissolve the common boundaries. And you can also extract, say you enrich your data with additional information. Then you can extract it to a local file geodatabase, local shapefile, and use it in other products. Okay, now Vicky will walk you through the workflows.
Can everyone hear me okay? Okay. So for those of you who've done some analysis in ArcGIS for desktop, this will look very similar, the workflow that you use in ArcGIS Online. So I'm just going to give you a short overview and then go a little bit more in depth to the different steps in the workflow. You start off by preparing your data, which in ArcGIS Online is quite a bit easier than in desktop often because there's a lot of data that's available for free online. You add your data to your map. You perform your analysis just like you would in ArcGIS for desktop. And then you review your results, which is sort of like a part of performing your analysis because computers can only give you tools, but you have to do the actual analysis yourself. So to start off, you prepare your data, and we have a lot of data types that are supported in ArcGIS Online, and there's a list of them here. They include feature services. You can use zipped up shapefiles. There are a few different online feeds that you can use, and I'm going to show you some of these right now. So I'm going to start off, I'm actually going to show you how to get into ArcGIS Online. You go to arcgis.com and sign in to your organizational account. I've already signed in, and then I've gone to My Contents. So here in My Contents, I have all of the data available to me in ArcGIS Online. I have a map image layer. I have all kinds of feature layers. I also have web maps in other folders. But how did I get all of these data layers into ArcGIS Online? One of the ways is you can use ArcGIS for desktop. I'm going to use ArcMap. Go to File and sign in to your ArcGIS Online account from ArcGIS for desktop. Then go to Share As Service, and I'm going to share this traffic data to my ArcGIS Online account. Going to Publish a Service. Make sure that your organization is in your connection. You can put in a service name. I've already shared this, so I'm going to put traffic 2 so it's not the same name. And then you go into your service editor and your capabilities, make sure that it's feature access that's checked off so that you can do analysis on the layer. And your item description, your summary, tags, and description are required for you to share the data. Then you're going to analyze it. If there are no errors, you can publish your data. And I've already done it, so my traffic layer is here in my contents now. There are a few other ways that you can add data as well. If you go to Add Item from my computer, you can browse to some of the different supported data types. I have a zipped up shapefile here that I could add. I also have a CSV that has latitude and longitude fields. So I'm just going to show you that. You could also have addresses, and you could use geocoding to, if you have the address, just check off the address here. Add your tags, check that your latitude and longitude fields are correct, and then you can add your item that way. Another way you can add a CSV is to go straight into your map viewer and just drag and drop your CSV from your Windows Explorer straight onto the map. Once you're in your map viewer, you can also search for layers. I'm going to search for layers from ArcGIS Online. I want some roads. So when I search, there are all kinds of different layers that Esri has provided, plus some other people have made their layers available to everyone online, so I can have access to those as well. I can also search for Esri's Living Atlas layers. There are all kinds of different categories here I can choose from: landscapes, transportation, boundaries, and get data that way. And the last way I'm going to show you is by adding a layer from the web. I'm going to use a live feed. You can use a bunch of different feeds. You can use KMLs, you can use online CSVs. I'm going to show a GeoRSS because it's a live feed. And I'm here on the USGS website for earthquakes. And I'm going to find all of the earthquakes from the past day. I'm going to copy that URL and just paste it in here and add my layer to the map. And yesterday, there was an earthquake right by San Diego, but it's not on there anymore, so I guess I can't show you guys where the earthquake was yesterday. Okay.
Is there a size limit, like limitation, like if you were to import it from your desktop?
Not from your desktop, but it's 1,000 for CSVs, or no, there isn't a limit. As actually, if it's more than 1,000, it will just publish as a feature service, and if it's less than 1,000, it's published as what we call a feature collection. So really, there's no limit.
Okay, so now that you've assembled your data, you want to update your map. And as we saw with the GeoRSS feed, that data gets updated automatically. But my traffic data that I exported from ArcGIS for desktop just went into my contents. So if I want to put that on a map, I need to go back into my contents, hover over this arrow, and I can click Add Layer to Map. And since I already have my GeoRSS data in a map, it will add the traffic data along with the GORSS data, or if I don't want that, I can add this layer to a new map and then delete the old map and create a new one with just the traffic data. Some of the other things I can do once I'm in my map viewer with my data is I can set my symbology, and that's called style in ArcGIS Online. I can change the extent, make bookmarks. I can save my map so that I can use it again later, and I can share it as well with people in my organization or with the public. And just as a side note, the Living Atlas analysis layers, they're a little bit different than the Living Atlas layers that I showed adding to the map earlier, as well as the custom analysis layers do not need to be added to your map in order to be used in your analysis. And Gian is going to show you a demo later that uses the Living Atlas analysis layers. So now that you have all your data in your map, you're going to want to analyze it. So we go into Perform Analysis, and there are two different ways of opening the Perform Analysis pane. And I'm going to show you both of them. There's an analysis button in the menu as well as in each layer. And you can go to your pop-up help icons here to get information about each of the tool sets as well as about each of the tools. So we've opened up the Summarize Nearby help. There's a description of the tool, and there's also a workflow diagram that explains what types of inputs and outputs and process are going on in that tool. So this one just says that there are two inputs. They can be points, they can be lines, or polygons. And the process will be finding a focal point and then summarizing a distance around it. And the output is that summarized area as well as a chart. So now that we've chosen Summarize Nearby using the description and the workflow diagram, we can open up the tool. There's a list of parameters that you can change. There's also help for each parameter. And hopefully you won't need it because the parameters are normally set with pretty good defaults. And you'll see in some of our demos that you may not even have to change any of the parameters, and you can just run the tool straight. So that's one of the really great things about ArcGIS Online is that it's really streamlined, it's very easy to use, and the defaults are often all you need to run the tool. And finally, now that you've done your analysis, you're going to review your results. Each feature has a pop-up that can be, you can click on the feature to open it up. You can configure your pop-ups so that only the attributes you want will be displayed. And you can change the labels for each of the attributes as well. You can also open tables just like you would in ArcGIS for desktop. And you can share your results with your organization or with the public in the form of story maps and apps. So I'm going to show you a few demos now. And my first demo is about finding a site for a new golf resort. And I'm going to filter data and overlay my layers to find out if there's enough privately owned land to make a golf resort. So my scenario is that a development company is looking to open a new golf resort in a budding retirement district. The company needs to know if there's enough privately owned land in the desired area that could be bought and used for the new development. So the company has already chosen 3 counties that are centrally located in the state and have existing golf resorts and plenty of baby boomers nearing retirement age. So they have a counties layer. It's these red outlines of their polygons. There's also a land ownership layer, and that's these green polygons. So we know that there are 3 counties that the company wants to look at. So instead of keeping all of the county layers, they're going to filter out the data. So the county name is in the alt name field. I'm going to check the unique value, and then I can search for the county that I need. And there's 3 of them, so I'll add another one. and my third one. And my counties, none of them are going to have all of those names, so I'm going to switch that to any and apply my filter. And now it's only the 3 counties that I'm going to be looking at that display on the map, and they're the only 3 that will be used in the analysis. I'm going to do the same thing with land ownership because we're looking for private land, but I'm actually going to filter out the private land, which uses the letter P. And the reason for that will be a little bit more clear once I run my overlay. So now I have my 3 counties, and I have all of the land that's not private. So I'm going to open up the analysis pane using this Perform Analysis button from the Counties layer. I'm going to go to Manage My Data and Overlay Layers. So because I used the Counties layer to open up the analysis pane, Counties is the first input in my Overlay Layers pane. And my land ownership is the layer that I want to overlay. I'm going to choose Erase so that all of the polygons that are in the land ownership layer, the ones that are not private land, are going to be erased from the county polygons, and that's going to leave only the privately owned land. And I'm going to keep my current map extent checked so that the analysis will only take place within this extent. I can also show my credits to see how many credits it will consume when I do my analysis. And I'll run my analysis. And that tool is really easy to use. If you've used any of the overlay tools in ArcGIS for desktop, you may realize that intersect, union, and erase are all separate tools in ArcGIS for desktop, but in ArcGIS Online, they've all been combined into one tool. So if you know you need to do an overlay, but you're maybe not sure which one you're going to use, all 3 of them are there in the same tool, so you can look through it and decide all within that same tool. Now hopefully it'll finish running. There we go. Just wait for it to draw. There, so there's all of our privately owned land. I can uncheck my land ownership now. And this is all of the land that the development company can look at to decide if they can build a golf resort here. So just to go through that demo, we added the counties and the land ownership layers to our map. We filtered out the counties and the land ownership data that we didn't need. And then we did an overlay to find only the private land within our counties and reviewed our results. My second demo is about a preliminary environmental assessment of wind farms. I'm going to create view sheds and find some overlapping areas. So the scenario for this is that a large-scale wind farm project is underway. In-depth environmental reviews must be done on the wind farm site applications, but the list of proposals will be narrowed down first to remove any proposals that are located on or within view of protected lands. So I'm going to go back into ArcGIS Online. And I have my protected lands are here in green. I have wind farm sites. The legend here shows the different colors. The approved and installed wind farms have already done the review and they've already passed. So I'm not going to focus on them. I'm going to focus on the applications and the scoping. And so those are ones that have had little to no environmental reviews already. I also have points for each of my protected areas, and they're going to be used as observer locations for when I do my view shed. So I'm going to open up my analysis pane, this time from the menu. I'm going to find locations and create view shed. So the create view shed tool uses the elevation data in ArcGIS Online to determine what can be seen from each observer point based on the height of the observer as well as the features that it's observing. So I'm going to put in my protected area points. I could also draw points directly on the map using this draw tool. And then I'm going to set my height of my observer, which is going to be 1.78 meters tall. That's about 5'10". So that's the average male height that I expect to be seen in my protected areas. Going to set the height of my wind turbines to 100 meters. And my maximum viewing distance is 50 kilometers, which is the maximum for this tool. And I decided to use meters and kilometers because the data is in a projected coordinate system that uses meters. So I wanted to keep that consistent for the analysis because ArcGIS Online will use that projected coordinate system when it calculates the distances. So I can also I can change my layer name if I want. I'm going to uncheck use current map extent for this because the view sheds could extend outside of my area that I'm zoomed into. And I can also show my credits to see that 0.01 credits is going to be consumed. I'm not going to run this tool because it takes a few minutes. I'm just going to show you the results that I ran ahead of time. And so here's my view shed. You can see that there are some areas where the view shed overlaps with some of my sites, and some of the sites are overlapping the protected areas as well. So now I want to select out only the sites that are fitting my criteria. So I'm going to go into Find Locations and find existing locations. I want to select from the wind farm sites, and I'm going to add my expression. I want wind farms that do not intersect my protected areas. And I also want wind farm sites that do not intersect my view shed. And if this was ArcGIS for desktop, I would have to run this selection and then do a select by attributes. But since this is ArcGIS Online, I can also search for wind farm sites with the status of application and the wind farm sites with the status of scoping. So now I have all of those expressions in here. I want to change this AND operator to OR, so I'll just click that to change it. And I want to group my two status selections so that I'm selecting either one or the other. So now my expression would read that I want wind farm sites that are not on protected areas, they're not visible from protected areas, and the status is either application or scoping. So I can run this analysis, and I'm going to end up with the wind farm sites that meet all of my criteria. And that's a lot easier to do this entire function within one tool without needing to switch from select by location, select by attributes, and then export the selected features. You can do it all within the same tool. So my selected wind farms are there. I'm just going to show ones that I've changed the style of these ones. And now I can open up my table, and I see that there are 25 wind farm sites that have passed this preliminary review, and I can now do a more in-depth environmental assessment of those sites. So just to recap that demo, we added the protected areas, wind farms, and protected area points to the map. We created a view shed, and then used Find Existing Locations to query out the sites that met our criteria, and then reviewed our results. My final demo, before Gian takes over again, is about investigating response times for fire trucks. And I'm going to create drive time areas using traffic conditions. So my demo scenario is that a city is conducting a review of its departments, and the fire department's review includes a look at response times. The fire department aims for 4-minute maximum response times to fires in the city. So I have my fire station locations here in ArcGIS Online. I also have the city's boundary that I'm not going to use in any analysis tools, but I'll use it when I'm reviewing my results. So I'm going to open up my analysis pane. I want to find proximity, so I'll go to Use Proximity Tools and create drive time areas. I have my fire stations as my input. I want to find the drive time of 4 minutes. And I want to use my traffic conditions, but I don't want them to be live traffic conditions. I'm going to look at traffic conditions that I think are really heavy traffic so that we can find the minimum distance that the fire trucks will be going within 4 minutes. So I'm going to choose Friday, rush hour. So I'll use 5 o'clock p.m. And then I want to dissolve any of my areas that meet each other so that they'll all become a continuous area if they meet. I'm just going to change this to the minimum travel. I'm going to uncheck use my current map extent, because if the fire trucks go outside of my current extent, I want to see that result. And I'll run my analysis. So I don't know if any of you guys have used Network Analyst in ArcGIS for desktop, but this process is a lot simpler in ArcGIS Online. Your network is built right into ArcGIS Online, so you don't need to find your network data set and prepare all of that before you run the analysis. So if you're using networks not too often, but you just want to use them every so often, ArcGIS Online is a really great place to use to do that analysis.
Yeah, just to add that, it really, for our organization, it saves you the effort to maintain and keep your network data updated, because we host this data. We actually make sure that it's the most updated data. Okay,
so I have my travel distances, my 4-minute travel distances here. And of course, the city is not very happy with that. There's a lot of area that's not being covered, but they also realize that it's the minimum, so they want to see maybe if the traffic is less heavy, it'll affect the drive time. So you run the analysis again using Tuesday at 2 a.m., which I've already done. And now you can compare the two distances. And it's a little bit better on Tuesdays at 2 a.m. when the traffic is lighter, but there's still a lot of the city that's not covered. So the city is probably going to want to think about adding in a new fire station. So to review that demo, we added our fire stations layer for our analysis. We created drive times for Friday at 5 p.m. and also for Tuesday at 2 a.m. And then we compared them when we were reviewing our results.
Thank you very much, and that was great. Now, I would like to remember that fire trucks demo that you have different drive times and the city doesn't get all its area covered. So what if you want to build a new fire truck? What if you want to build a new fire station? And the criteria normally when you build a new fire station is you want to minimize the travel cost for the fire trucks, and you want to maximize the demand and the service for your demand, which is the population of your city. So when the travel is involved with the travel cost, and when you have a demand that you have to serve, we use this tool called Choose Best Facilities. I really want to show it because this is our brand new tool that we just released last year. And this is, anyone are familiar with location allocation? Okay, great. Then you don't need to, that's our existing algorithm used in Network Analyst. So basically, when you are in a transportation network, and there's always a travel cost. The travel cost can be travel time or travel distance. So that's what the first thing we want to minimize. And then when you find a best location to build a new facility or choose an existing facility, and you always have a service area in mind, right? You want to maximize. I gave you an example. You want to build a new neighborhood park. The goal probably is you want to serve as many people as possible in the neighborhood, and they have to walk at least amount of time as possible, and then that would be the best location to build your new park. So let's see a demo for that. My demo scenario is that this is a county in North Carolina. I happen to have data, and I have existing 8 health clinics. In the flu season, I may want to add some additional mobile clinics so that I can give people flu shots, because when there's high demand for that. So in the past, we always use library locations as the place to put the mobile clinic, because they're easy for people to find. And there are many existing libraries in the city, but I only have budget to add 4 mobile clinics. So the problem I want to solve is which 4 existing libraries should I choose that minimize the travel cost for my population in the county and maximize the coverage of all clinics, including the 8 clinics that I have. Let's see how we can what's the approach we can take to solve this problem. So here I have in my ArcGIS Online, this is a default web map viewer, and I have my county boundaries. And I have my existing 8 health clinics, and I also have all the locations for my public libraries. So I'm going to go analysis, find locations, and choose best facilities. And there are different goals I can achieve, and in my specific purposes, I need to maximize the coverage for my new mobile clinics. So I'll choose that. And the measurement for my travel cost, I want to choose drive time. You can also choose walking time for a neighborhood park, probably walking time or walking distance. So in my case, I'll choose drive time. I'm going to use just average traffic. And the travel direction, in this case, I have the population in the county driving to the clinic, so it will be demand to facility. And demand location layer, which will be the population in my county. So what I did was I went to I use to me, it makes sense to use census block groups centroid points for the county. And how did I get these? And I got it by choose living atlas layer. I can say census block. Gosh, just say block groups. So I have USA Census block group points data. And what is this living atlas analysis layer? This is the one that we noticed that a lot of our users run analysis based on common boundaries, like county boundaries, zip code boundaries, state boundaries, or census block groups, census tracts. These are very commonly used boundaries. And how many of you have been like, oh, I need to find the county boundary layer? Yeah. So what we did was we provide all these layers, which we think commonly used. And it is an evolving process. We're constantly adding more based on demands. So you can just say, hey, I need zip codes. You just type zip code. And then we have these layers provided that you can use for analysis. And there are 2 criteria. First, they are commonly used boundaries. Also, we optimized the storage for analysis performance. So it would be actually faster than you acquire your own county boundary layer and publish it as a feature service, and using ours will be actually a tiny little bit faster. So that's how I got my census block group points. So I'm going to say this is USA Census Block Group central points will be my demand layer. And the amount of demand, one of the field in my layer is called population 2014, indicates how many population, what's the total number of people living in that census block group. So that will be the number of demands. That's where it's coming from. And the maximum travel range, I would say 10 minutes. This means I don't want anyone, any of my demand point, which is people living in my county, drive more than 10 minutes to a clinic, okay? And then I say, what's the required facility layer, which are the existing health clinics? They already provide service to my population. And the candidates are the public health, the libraries, the public libraries existing in my county. Remember we said we only have budget for 4. So we'll just say, specify, we choose 4 candidates, and then I probably had the existing name already, so I'll just give it a different name, and I can just go ahead and run this analysis. So as it's running, I'll show you the results from my, I still have, well, that name already existed. I probably used it yesterday. But without wasting time, basically it just runs it and then use one of the network location allocation solvers and solves that problem. As you can imagine, that's actually a pretty complex algorithm. And it's based on the transportation network behind the scene. But our goal is to make the user experience as intuitive as possible. So here I want to show you the results. This is the results facility layer. So you can see that there's this diamond points. These are my existing health clinics. And I also have these squares. These are the public libraries. The red ones are the ones that are not chosen. The 4 green ones are the one that was chosen. And if I draw these are all the population's demands that's being served and not being served. This one shows me the lines, which population points will travel to which health clinic. Okay? Similar as what Vicki did, I'm going to quickly summarize what we saw in the demo. So in this demo, I had existing clinics, library locations, census block group send choice, which I add them to my web map. And then I use choose best facilities to maximize the coverage for my health clinics and choose from existing locations. And I have a limit of only 4. So then we reviewed our results to see if it really suits our purposes. So in my next demonstration, it's actually one scenario, but contains many different demos. So scenario is pretty easy. I have data that I downloaded from California Department of Education, public schools data. And in this data, there's one measure called API. It stands for Academic Performance Index. And this is API. This values from 300 to 900. And the higher the number, the better it's supposed to be for its academic performance. So I would like to analyze if are there any spatial patterns for the school's performance, other neighborhoods that has consistently high performance schools, and other neighborhoods that has low performing schools, and what could be some possible influence to the school academic performance. So here I have more than 7,000 public schools that I downloaded from the education department. And they do publish this data and make this API information available. So I create a style of the map. I'll show you. This actually, the color indicates the API score. So it's like ranging from 700 to upper almost 900. So the darker the color, actually the poorer the school's performance. Even though I classify the data, it's really hard to see any spatial patterns because a lot of points are overlaid on top of each other. It's really hard to see anything. So one thing I can do is becoming kind of popular these days is called data binning. So what I can do is I can create equal-sized bins, equal area, and then I aggregate my point data within each of these data bins, and then create an average for each of my bins. Then I can probably review the spatial pattern better. So I can use, traditionally we use fishnet, and now getting more and more popular, people use hex bins for analysis. And hex bins are one of the layers we provided in the Living Atlas analysis layer, and with different resolutions. So what I have here is hex bins for state of California in 10 kilometer by 10 kilometer size. And what I can do is I can go to analysis and say summarize data, aggregate points, and I want to aggregate my California schools and to my hex bins in 10 kilometer resolution. And I would like to create, I don't want to keep the areas that do not have any schools fall within it. And I would like to summarize my API score and create an average for each of these bins. Okay, and I have some additional options. I'm going to leave it as a default, and then just go ahead and run this analysis. This is because there's so many hex bins for the whole state, it would take a while. So I'll show you what I have. So let me zoom to a closer area so we can see better. So I zoom somewhere in central California. The darker red are poor performing schools, more poor performing schools than from the green is better performing. Now the spatial pattern seems more obvious. Yeah, I can identify each of these hex bins. It tells me in this particular bin, I have about 20 schools. I have 20 schools fall within it. The average API is 753. If I click here, there are about 4 schools in that bin, and the average API is 906. Okay, it looks fairly okay in the state level. Let me zoom in to Los Angeles County area. So if I show the same hex bin in this if I zoom to a Los Angeles County level, it seems like for analysis, this level is the resolution is too coarse. So what I can do is I have 1 kilometer hex bins for LA County, and I can perform the same exact analysis for schools in Los Angeles County, and here's my result based on a different resolution hex bin. Let me turn off this one so you can see better. So now you can see clearly some spatial pattern for schools' performance. So we can see the red, darker red part are the lower performing schools, and the green ones are better performing schools. Okay, so that's one way to review spatial patterns by data binning using aggregation. And then another way I can do is, what if I want to identify statistically significant hotspots and cold spots based on my school's academic performance? So what I can do is I can go to analysis and analyze patterns and find hotspots. I can say, based on Los Angeles public schools, and give me the hotspots and cold spots for the API score. So hotspots, cold spots, API. Okay, so I'll just go ahead and run this analysis. So the results are including the visually. You will see where the hotspots are, where the cold spots are. And if you check the attributes, it also returns to you a z-score and as well as a p-value. So without going too much into statistics, so if you have a hotspot, and then that means you have a relatively high z-score in the positive value and a low p-value, that shows you this point is a hotspot that is purely random. The chance of that is low. So you can have a higher confidence to say that is that school is a hotspot. And hotspot meaning the score is high, and the cold spot means the score is low. Okay, so now we can clearly identify the spatial pattern based on my school academic performance. How many of you are relatively familiar with LA County? Okay, so you can see that, probably know, you have an idea where these areas are. I know that this one has a high performing school neighborhood. That's actually West LA, Beverly Hills area. So my first intuition is, could this be related to income somehow? Okay, so I have my hex bins, but I don't have income. Remember the enrich data tool that I talked about earlier? And this is when I can use geo-enrichment to acquire the mean household income, which is part of the census data. I can acquire that data and enrich my existing data so that I can do my analysis. I can compare that with my school's performance spatial pattern. So to do that, I go to analysis. I go data enrichment, enrich layer. And the layer I would like to enrich is the LA County hex bins data. And then I can select which variables I would like to enrich. First of all, it knows that my data is in the US, so it automatically chooses the country for me. And if you have interest in other countries, here are the list of countries that we have data. And each country will have different set of attributes. And then here for the US, these are all the categories of data that you can choose from. And if you go to each category, you have more variables. So you can browse it that way. Or in my case, I can just simply type income. So it will show me all the income data that we have available in our data set. So what I did was I chose the median household income and enrich my data with that. So let's just go ahead and show you what I had done. So here's the hex bins with the income that acquired through enrich layer. So I purposely made the symbology that the darker red is actually low income, the blue ones are higher income. I also, let me zoom in a little bit on this map. So I also configure the pop-up, so I can see, I use the chart for the pop-up, I can see that for this specific hex bin, the income is about 29,000, 30,000, and as compared to the county medium, which is 55,000. So it clearly way below the county medium. And as of this one, it's clearly higher than the average of the county. So what else could be related to my school's performance? And I just think maybe crime. So I have crime incidence data for the whole Los Angeles County. So the first thing I did was like what Vicky did in one of her demos. I think what's most relevant to schools' performance is the gang-related crime. So the first thing I did was filter my data to say, give me only the crimes that is gang-related. So I have that. So these are all the gang-related crime. So the next thing I did was I went ahead and then create a density map of density map of the gang-related crime in LA County. So this, as that is running, I'll just show you. So this is the density map. So as you can see, these are the areas that has a high occurrence of gang-related crime. Okay, so I can go one step further. Say, what if I have schools that I don't have API scores, right? That happens. Sometimes I have areas I do not have information about this academic performance. So we can use spatial interpolation to produce a predicted surface so that anywhere within my study area, I can get a predicted value. So based on our existing schools with API scores, I did interpolate points. I interpolated and then created output. Here's the interpolate surface of the API score in LA County. The darker the area, the higher the score. So I get an idea where are the low values, where are the high values. And I could improve this. I did a quick and dirty demo. I could improve this by cutting out the areas which I know have nobody lives in. So then that will make it better because some of the area appears to have low scores, but really there's no population there. So I should be able to use the census block groups as a mask and mask out the area with no population. So the powerful thing about interpolated points is that it not only can output the prediction surface, it can also output the standard error. So we can say with what confidence we have with our predictions. Okay, so these are a lot of analysis that we've done using ArcGIS Online. So how do I share my result? What if I want to share my results with school board, with the public even? So what I can do is I can create a web application and just give the URL of this web application to anyone. If I share it to public, anyone can just view this. And this does not require them to be a user of ArcGIS Online. And this is just a regular web app. So with this web app, I put 4 maps together. My school performance hotspot, cold spots map, the median income, the crime density, as well as the aggregation to hex bins that I did. So I can link these 4 maps. So let me zoom to this area which that seems to have poor school performance. I can see that it has high crime density, has clearly the same pattern reviews in aggregation, also a low median household income. And this is a powerful way of sharing your analysis results. And I want to give you a quick idea how easy it is to generate this web application. So what I did was I share my web map, and I say, hey, I want to create a web app. I chose one of the existing templates that we have called compare analysis. And then all I did was configure this template, add my web maps. I did not have to write any code, and then that is published as a web app. And of course, if you have developing capabilities, you can download this template, modify the source code, and publish it again. Yeah, it's one of the options. That's how the template defined. Okay, quick review of what we saw. We have the data, which is public schools with API scores. First thing I did was aggregate these points into hex bins. I did it twice. One is at the state level using the 10 kilometer by 10 kilometer hex bins, and one at the LA County level, which is 1 kilometer hex bins. And that allows me to identify which neighborhoods have higher or lower API. And then I created the hotspot cold spots, and that allows me to find out the hotspots and cold spots also with the statistical significance. And then we did density analysis based on the gang-related crime events. We use enriched layer to get the median household income information, and I use interpolated points to create a prediction surface for my whole study area. And then we review the results, and then we share the results as a web app, and I chose the comparative analysis template. There are many templates available. Some of my favorites are, like, one allows you to swipe between two maps, so you can see the change. If you publish something that before and after, that swipe template is powerful. Yes?
In your comparison analysis,
yeah.
Is there a way to add a legend so that people can read it?
It's already there. Let me see.
Okay.
Yeah, as part of the template. Okay. Okay, I have 2 minutes left. We can quickly wrap up. Just to wrap up, by having analysis in ArcGIS Online, it really provides additional insights to your spatial data. And then our goal is to make online analysis, the user experience, to be easy and intuitive. So please go ahead and then start using it and give us feedback, see how we can improve. And also, we would like to have feedback for this tech workshop. It's Vicky's first tech workshop, so tell us what we can do to improve, and tell us what you like and you don't like. And I think this year you can only do the review using your app. Okay, we'll stay around for questions. Thank you.
There's someone in the back.
Oh, yes. It's actually not that much. For basic analysis, every 1,000 features only costs you 1 credit. So, but for the only one that for the enriched layer is based on how many variables and the total number of features you have. So that's like you're buying data. So that's a little bit more expensive. But it's the number of variables times number of features divided by 10. Yeah, all these formulas are published online.